Well, let me ask you. There's a guy named Elon Musk. There's a company called Neuralink, and there's a general field called brain-computer interfaces.
Yeah.
It's kind of interface between your two loves, which is
Yes.
the brain and the intelligence. So there's like very direct applications of brain-computer interfaces for people with different conditions, more in the short term.
Yeah.
But there's also these sci-fi futuristic kinds of ideas of AI systems being able to communicate in a high bandwidth way with the brain, bidirectional.
Yeah.
What are your thoughts about Neuralink and BCI in general as a possibility?
So I think BCI is a cool research area. And in fact, um, when I got interested in brains initially, so I was enrolled at Stanford, and when I got interested in brains, it was through a brain computer interface talk that Krishna Shenoy gave. That's when I even started thinking about the problem. So it is definitely a fascinating research area, and the applications are enormous, right? So there is a science fiction scenario of brains directly communicating. Let's keep that aside for the time being. Even just the intermediate milestones they're pursuing, which are very reasonable as far as I can see, being able to control an external limb using direct connections from the brain, and being able to write things into the brain. So those are all good steps to take, and they have enormous applications. People losing limbs being able to control prosthetics, quadriplegics being able to control something. And therapeutics. And I also know about another company working in this space called Paradromics. They're doing, it's based on a different electrode array, but trying to attack some of the same problems. So I think it's a very
Also surgery.
correct surgically implanted electrodes. Yeah. So I think of it as a very, very promising field, especially when it is helping people overcome some limitations. Now, at some point, of course, it will advance to the level of being able to communicate.
How hard is that problem, do you think? Okay, let's say we magically solve what I think is a really hard problem of doing all of this safely.
Yeah.
So like being able to connect electrodes and not just thousands, but like millions to the brain.
I think it's very, very hard because you also do not know what will happen to the brain with that, right? In the sense of how does the brain adapt to something like that?
And it's, as we were learning, the brain is quite, in terms of neuroplasticity, is pretty malleable.
Correct.
So it's going to adjust.
Correct.
So the machine learning side, the computer side is going to adjust, and then the brain's going to adjust.
Exactly. And then what soup does this land us into is
the kind of hallucinations you might get from this.
Right.
They might be pretty intense.
Yeah. So
just connecting to all of Wikipedia. It's interesting whether we need to be able to figure out the basic protocol of the brain's communication schemes in order to get them to the machine and the brain to talk. Because another possibility is the brain actually just adjusts to whatever the heck the computer is doing.
Exactly. That's the way I find that to be a more promising way. It's basically saying, okay, attach electrodes to some part of the cortex, okay, and make sure maybe if it is done from birth, the brain will adapt. It says that that part is not damaged. It was not used for anything.
Yeah.
These electrodes are attached there, right? And now you train that part of the brain to do this high bandwidth communication between something else, right?
Yeah.
And if you do it like that, then it is brain adapting to, and of course your external system is designed such that it is adaptable. Just like we, design computers or mouse, keyboard, all of them to be interacting with humans. So
Yeah.
of course that feedback system is designed to be human compatible, but now it is not trying to record from all of the brain, and now two systems trying to adapt to each other. It's the brain adapting into one way. So.
That's fascinating. The brain is connected to like the internet. It's connected. Just imagine just connecting it to Twitter and just taking that stream of information. Yeah. But again, if we take a step back, I don't know what your intuition is. I feel like that is not as hard of a problem as the doing it safely.
Um,
There's a huge barrier to surgery,
right.
because the biological
Correct.
system, it's a mush of like weird stuff.
Correct. So that the surgery part of it, biology part of it, the long term repercussions part of it. Again, I don't know what else will. We often find after a long time in biology that okay, that idea was wrong, right? So people used to cut off this the gland called the thymus or something,
Hmm.
and then they found that oh no, that actually causes cancer. So
Yeah. And then there's a subtle, like, millions of variables involved. But this whole process, the nice thing, just like again with Elon, just like colonizing Mars, seems like a ridiculously difficult idea. But in the process of doing it, we might learn a lot about the biology of the neurobiology of the brain, the neuroscience side of things. It's like, if you want to learn something, do the most difficult version of it
yeah,
and see what you
and
learn.
the intermediate steps that they are taking sounded all very reasonable to me. Again,
Yeah,
yeah. So
it's great.
yeah,
Well, but like everything with Elon is the timeline seems insanely fast. So
right.
that's the only open question.